All right. Yesterday we dealt with area rule, and today I want us to look at the sine rule. And at the end of this lesson, we should be able to calculate the lengths and the angles of triangles that are not right angled. But I want us to look at the relationship of the angle and its opposite side. Now, when we're talking about the right angle triangle, as we know that the hypotenuse is always opposite the right angle. But then you would agree with me that the right angle is the biggest angle here within the three angles, between the three angles, right? So that's why the hypotenuse is the longest. So that would mean that here, opposite 30 will have the shortest side. And then here, opposite 90 will have the biggest side. And then here we'll have the middle of these two lengths. Let us look at that one. If you have, that's an equilateral triangle. And in an equilateral triangle, you will have 60, 60, and 60. So that means all your sides will be the same, right? So side, 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 whatever, because here it's 60, 60, and 60. Let us look at an equilateral or an isosceles triangle. In an isosceles triangle, let's say this one is 25 and 25. Here you will have 130. So that will be your longest. That will be your longest side. And this side will be the same. Let's call it side, side, right? So now we know that now the relationship, there is a relationship with the side and the angle opposite, or the angle and the side opposite, okay? So keep that in mind. But now, let us go and look at this kind of a triangle. Here we have your A, your B, and your C. And remember that we said opposite the angle, we have a small a, and opposite C, we have small c, opposite B, we have small b. Okay? And yesterday, we had a triangle like this and we created an altitude. We constructed an altitude. So I want us to start from there. So let us construct an altitude here. An altitude that will be perpendicular to the base there. And we know in this case that will be your what? That will be your h. But when we construct now, let's call that point x so that we know there is ax and cx and xc. Because now we've got two triangles. Yesterday we used one triangle and today I'm going to try to use two triangles. Okay, so in triangle, let's look at triangle. Let's look at triangle ABX. And let's put an angle there. Let's say that angle is theta, and that angle is, let's say it's alpha. So we understand that here now we are looking at a different right angle triangle. So that's the one we're looking at. So there, sine theta will be equal to your h divided by your c. Your h divided by your c. And now let's look at the second triangle, which is this triangle, okay? I'll call it BCX. By the way, this small b is opposite that one. That's for the whole length of AC. Okay, back to that. In triangle BCX, sine C. I'm saying sine C here because that's the angle, and sine A, that is the angle. So sine C is equal to H over A. H over A. But then I've got H on both of them. So what will my h be? Because h is common, but it's different from this triangle and it's different from this triangle. So what is it going to be? So your h here, we not say is equal to, we say h therefore will be equal to sine c multiplied by sine theta multiplied by c. Sine theta multiplied by c. And then h here will be sine c multiplied by a. So now you see that they are both equal to h, so that means they are equal also. So let me put them like this. That would mean sine theta, let me call it c sine theta, is equal to a, not sine theta, it's sine c sine, let's change that for a. Let's change that for a, sorry. So that will be a. Okay, so c sine a is equal to a sine c. But then now we want to maintain. Remember that we said the angle and the opposite side, there is a relationship. We want to maintain that relationship. Okay, so in this case, how can I make sine c relate to side c? So I will say, let me divide. I can either divide by, or let's divide by CA on both sides. So if you divide by CA on both sides, or AC, you are going to cancel that and that. You're just trying to rearrange, right? So you are going to have your sine A over A, which is equal to sine C over C. But then we know that that will be the same for the other side also, like we said there. So there should be some relationship. So I'll continue then and say that will be the same for B. And people, now we have created or formulated sine rule. So that is the formula, that is the sine rule formula. We've derived sine rule formula. So this also will be the same. This can be, because if we divide by sine C, sine C, sine A, sine C, sine A, and sine C, sine A there, so you will have sine, oh sorry, not that. It's also the same as A over sine A, B over sine B, C over sine C. So if you are looking for an angle, make sure that your angle is on top. And if you are looking for a side, make sure that your side is on top. Remember, the small letters represent your sides, right? So make sure if you are looking for the side is on top. If you are looking for an angle, then the angle is on top. Okay, I'll stop there for now. In the second video, I'm going to look at 2 examples